Okay, hello everyone. So today we will tackle thermodynamics, and in particular, this video will cover the calculations that are involved with thermodynamics, so specific heat and the calorimetry equation. Okay, and it goes by this: Q is equal to mc delta T, wherein Q is equal to heat, m is the mass of your substance, C is the specific heat of the substance, and T is the temperature. Now, among those variables, perhaps the most unfamiliar would be specific heat. Now, this is very unique for each substance. It is a measure by which or how much heat per unit mass is required to raise the temperature of that substance. And it goes by the SI unit of joules per kilogram Kelvin. Okay, so each substance has a unique specific heat. So for example, steel would have a specific heat of around 490 joules per kilogram Kelvin. Glass would have 840. Wood would have 1700. Okay, you might be wondering, okay, why is wood so high when it burns so easily? Well, actually, it used to be a plant, and as a plant, it used to contain water inside those cells. So it actually has quite a lot of things that will resist the raising of the temperature. Okay, but once it catches fire, it really is going to burn. So next would be concrete. It really, you can cook an egg, right, in a road if it's too hot. So it has a low specific heat of around 880 joules per kilogram Kelvin. And finally, you have water, which has one of the highest specific heats that you can likely find, and that has a specific heat of around 4,186 joules per kilogram Kelvin. So as you could see, specific heat is a very distinct property of a substance, okay? And the study of thermodynamics and calorimetry all centers on selecting the substance that can resist or conduct heat depending on what your purpose is. So for example, okay, I want to design something that will absorb or rather transfer heat pretty quickly. So likely I'm going to pick steel for that substance because I need heat to transfer from one place to another. Okay, conversely, if I want it to take some time for the heat to transfer, I could say, okay, I'll compute, and then I know that water has one of the highest specific heats, so water would be ideal for resisting heat. So some of those calculations are going to be centered on the use of the calorimetry equation. So for example, let's start with a simple one. How much heat is needed to raise 5 grams of aluminum by 20 Kelvin, given that the specific heat of aluminum is 900 joules per kilogram Kelvin? Okay, so we know that these are the quantities. So Q is heat, M is mass, C is specific heat, T is temperature. Okay, let's try to solve it. So we know that we're looking for heat because it says how much heat. And we are given 5 grams of aluminum, 5 grams. But if we convert that to SI units, as we should always instinctively do, this would be 0.005 kilograms. Okay, next we have the specific heat, 900 joules per kilogram Kelvin. Okay, take note, this is over kilogram times Kelvin. And finally, you have temperature, which will give you a value of 20 Kelvin in itself. Okay, so based on this, I think we can just simply plug it into the equation. Q is equal to mc delta T. Okay, so what is Q? We're looking for it. M is given to be 0.005 kilograms. Okay, specific heat is given to be 900 joules per kilogram Kelvin. And finally, the temperature is given to be 20 Kelvin. So if we actually look at the units, they cancel out pretty conveniently. And we're just going to be left with joules, which is sensible that it is actually the SI unit for heat or energy. So let's get my calculator real quick. Let me keep my ink annotations as such. Okay, I don't know why I just did that. But anyway, let me get my calculator. Oops. Okay, calculator. So that would be 0.005 kilograms times 900 joules per kilogram Kelvin times 20 Kelvin gives me a value of 90 joules. So my final answer for this one should be 90 joules. Okay, so it's taking a while for my mouse to respond actually. Just quickly do this. Okay, so that should be, if I load it again, whoops, oh, sorry about that. My ergonomically designed uh, touchpad is making me press buttons I shouldn't be pressing. But as you know and calculated, it's going to be around 90 joules.